Today I'm going to do the 2013 higher level surface geometry question. It's C3 from the exam paper. The 3D graphic on the right shows the pop star Beyonce and her notable engagement ring. The brilliance of the diamond is determined by the accuracy and symmetry of the geometry used in its design. Figure C3 below shows the outline plan and elevation of the cut diamond. A pictorial view is also given. Part A. Draw the given plan of the diamond. Surfaces A and C on the top of the diamond have a pitch of 45 degrees. Draw the elevation of the top portion of the diamond, surfaces B, C and D. Part B. Determine the dihedral angle between A and B. Part C. All the sloping edges on the underside of the diamond have a true length of 9.5 millimeters or 95 millimeters when scaled. Complete the elevation of the diamond. And then part D. Determine the dihedral angle between the surfaces D and F. Now just note that the scale is 10:1, which we wouldn't normally see. It's an enlarged scale, so we have to multiply everything by 10. So 10 millimeters here goes to 100, 7.5 goes to 75, 2.5 goes to 25. I'm going to start by drawing the plan view of the diamond, and then I'm going to show you then how you can complete the elevation. Okay, so that's the plan view of the diamond. Now just a few things. These lines here are at an angle of 45 degrees because from the corner of the square that point is in 25 millimeters and so is that point, so it's in equal distance. So the angle must be 45 degrees, and similar with this line here. So the first thing you need to do is draw the outside outline of the diamond. Then join up your opposite corners, and then that will give you then the inner outline of the diamond. So once you have the plan view done, then the next step then is we're going to draw the elevation. So it says that surface A and C on the top of the diamond have a pitch of 45 degrees. Now I said that this is surface A here already. Okay, so we have surface A. So in elevation now we're going to be able to show that at an angle of 45 degrees. Okay, so there's surface A. When you project it up to elevation, it has a pitch of 45. So we can bring that down to 45 degrees. Now that gives us then that point there where it crosses A. We can bring that across then to get the top part of the diamond. And also this surface here will have the same pitch of 45 degrees. After that then we can put in surface C on the front. Okay, so that's part A of the question completed. So part B says determine the dihedral angle between surfaces A and B. Okay, so to determine the dihedral angle, there's two steps that you have to do. Step 1, I'm going to write the steps out here. This is my line of intersection here. So what I need to do now is project out a view that's looking perpendicular to that line. So using sliding set squares, my heights from my elevation of surface A and surface B. Now, because I don't have the full diamond done yet, I'm going to put in a datum line. So I'm going to put in a datum line right there along the bottom of surface A and surface B. Yeah, so there's going to be a datum line. So now I can take all my heights for each point from that line. So we can see that this point here is on the ground. So I can put a dot there, and that point where the other line of intersection is has that height. So I can take that height on my compass, follow that line out and mark that there. That there now is the line of intersection. This point here is on the ground, and then this point here is at the same height up as the line of intersection. Then we have this point here on surface B, which is on the ground. And then we have this point here, which is up at the height. So just to recap, the first thing I did was I looked up this way. Okay, and now what I'm going to be doing now is I'm going to be looking down this way along my line of intersection because I want to get a point view of it. So again, set up your sliding set squares. Now, when we're putting the measurements on this view, we always have to take them from two views back. So that's one view back, this is the second view back. So we're taking them from this view, and we're also taking them from our previous XY line. So we're on X2, Y2, so our previous one would be X1, Y1. So we're going to be putting our compass here and measuring back to this view here. Okay, now again, just to shorten up the question so I won't run out of room, I'm going to put in a datum line through point A. And all datum lines that I put in, I'm going to put them in green. So final thing to do then is to measure the dihedral angle. So I get a measure of 148 degrees. Now just be careful, you need to put in your dihedral angle symbols. So a little triangle there, triangle there, and the angle I got was 148 degrees. So that's part B. Part C of the question says all sloping edges of the underside of the diamond have a true length of 95 millimeters when scaled. Complete the elevation of the diamond. So what lines they're talking about there now are all the under ones. So this is the top of the diamond, and that's the very top surface. So it's the line going from here down to the point part on the bottom, there, down to the bottom, there, 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 and there. So all of them have a true length of 95 millimeters. But in the plan view, we cannot see that true length because them edges are sloped and they're slanted down to a point. So we have to be able to use that information to be able to find the true length of them lines. Now, one very important thing that will help you with this question is knowing the fact that any line that is parallel to the XY line will be seen as a true length in the other view. So if I can show one of these parallel to the XY line in plan view, then it'll be a true length in my elevation. So what I'm going to do is I'm going to pick one of the points. Doesn't matter which one I pick, and I'm going to rotate it so that it's parallel to the XY line in plan view. So the one I'm going to take is from here into there. So I'm just going to put a dot on both of them points. And what I'm going to do now is I'm going to rotate that line so that it's parallel to the XY line. So that's it there, and then I'm going to project it up in elevation. I know that it's 95 millimeters. So get that measurement in your compass. From this point, which is up here, scribe an arc that's going to cut that line that you brought up, and that there then is your true length line. That line there now is true length. Now that line is not the actual position of that line in the elevation of the diamond. So what I need to do now is I need to rotate it back into its correct position. So what that's after giving me now is it's after giving me the height above the XY line. So if I just bring up the center here, and then if I project across that point, that there now is going to give me the center of the diamond and that its height above the XY line. I can join up my points. So the last part of the question then says determine the dihedral angle between surfaces D and F. Okay, so I'm just after highlighting surfaces D and F there. So D is red, F is in green, and you can see the line of intersection then is the line that they both commonly share. So there it is in elevation, and there it is in plan views. There's surface D, and there is surface F. So again, I'm going to apply the same method, use the auxiliary method, that approach to getting the dihedral angle. So the first thing I have to do is get the true length of the line of intersection. That's by looking perpendicular to the line of intersection, and afterwards then I'm going to get a point view of the line of intersection, and that's when I look down along the line. So again, now to sharpen up my view, I'm going to put in a datum line. This time I'm going to put in a datum line just here at the bottom of the diamond. So the common point that they both share is on the datum line, so that means it's going to be on the ground out here. And then the top of the line of intersection then is going to be join up them 2 points. Now afterwards then I have to get this point, which is here, so that's up the exact same height. And then the other point here, which is at the same height as well. Okay, so in the first auxiliary view, surface D is out to the front and surface F is to the back. So there's our surface F at the back. And here then is my line of intersection. So what I need to do now is I need to get a point view of my line of intersection. And now again I'm going to put in a datum line, and I'm going to put it in then through the point that's closest to my x3, y3 line. Again, set up your x3, y3 line, project it back, and there's your datum line. So this point here then is going to be on the ground, which is there. And then I need to take the heights then for my other points. So I get a measure of 150 degrees. Okay, so that's the solution to the 2013 higher level surface geometry question. I hope it helped you, and I hope now that you're able to fully understand how to find the dihedral angle using the auxiliary method, that if any line is parallel to the xy line in one view, it's going to be seen as a true length in the next view. Thanks.